Hey guys, welcome back to another video. On this video that we're going to be doing is we're going to talk about inheritance. So this is something that we haven't talked about in JavaScript, and I thought it would be interesting to add this. We talked about it a little bit, but we never really got exposed to it a lot, and so I thought that it would be a great idea to, provide something. Alright, it would be good to provide something in that aspect. Alright, so we will do something a little bit different. Alright, so what we need to do is create a class. So let's say class. I think about vehicle is always a good reference. I use this in all my classes. So we'll describe in this class specific informations. So this will be our parent class, and what will happen is we'll derive and grab data back from the parent class, which will be our children classes. So how many tires are on a car? Usually 4, last time I checked. So then we have var class is vehicle. We have all right, we'll have var. I'll make this a little bit bigger. I can zoom in a little bit. All right, so that guy disappeared on me. So I had tires, and then I have the make, and we'll just make it a string blank for now. What that means is we're gonna declare it later on. All we're doing is initializing it, describing what it is, but later on we'll set a value to it. Okay. So now we need what? A model. So it'll be the same thing, string, and then we need a current speed. So let's do current speed, and we'll set it at a double because it might be 35 point whatever miles per hour. All right, so now we need to initialize this. So we need to do an init for initialization, and then we're just going to print a statement that says I'm the parent class. Okay, and then we could actually, oops, that little string is going to die on me here in a second. And you see where I have double is lowercase. It's case sensitive. It gets upset when you don't tell what to do. Oh, excuse me. All right. So initializes it. It doesn't work. Let me see why it's not working. All right, what did that do? Class var equals double equals 0. Initialization is fine. Let's see why. Because we do have this here. Oh, because all right, you know what? We initialized too early. We have to come back to initialize later on. So I got a little ahead of ourselves there. That's why it didn't work. So we'll come back to that one. What we need to do first is we need to set up a function. And we talked about how to do a function. We're going to do one for drive, and we'll do speed increase. And we'll say that we're going to accept a double for it. And within a double, we'll do current speed, which we are inheriting from this guy right here. We'll say plus equals speed increase. So whatever this is passed in right here. And we'll say multiple by 3. Something silly. So we have that. So we'll put here step 1, create class. Step 2, is create function that talks to parent. So it talks to parent. Then we need another function in there, and we'll call this function break. All right, so we'll need something for a break. Well, as you see, we'll get to that other one in a minute here. So we know what our number 2 was. So let's delete this and pretend it doesn't exist, and then it'll make more sense why we need it when we need it. All right, so let's do step 3, create function for breaking. All right, so now let's separate these guys a little bit. All right, so now what we're going to do is we're going to set up a subclass. And we'll get more specific on our subclass. So we'll do class. and we'll call it sports car. Vehicle, and down here we'll have to well, let's do this and I'll show you what happens. So let's come down here and say we'll do make equals, I'm gonna use something old, Pontiac, and then if we had to do model equals Trans Am. Okay, so in order to make this work, we have to do an override, because look right here, it says expected declaration, so it doesn't know what to do with this. So we need an override, so we'll do an override, initialization, and we need to do this, and within here, we need to do a super initialization, so we have to call another one. So now we have to copy these guys here, got this, throw it in here. So now we have to do this. And on top of that, so we'll put this as step 4. Now we need to go create that initialization that we had created earlier. If you remember, we had initialization at the top. Now we have to go back and create that. So, let's go up here to above drive. This will be step 5. Create a initialization, and this is what we had before. And we can do an init, and we can print we'll say print parent class. Perfect. So now we'll come back down here and we're going to intercept that into that layer down here. This done. Now let's go under super int right here, and let's do print, and we'll say child class. We'll just say child. Simple. And then let's do this right here. Let's also print something else. Here for the heck, I'll just say let car equal sports car. So what we're doing here is we are calling this class, this subclass, which should say, hey, sports car, because, let's see here. It should grab sports car because that's the class that we're calling. And then we should have, it should print child here, but it'll come up here first and print the parent class. So let's see if this works. Hypothetically it would work, and it does. So it says, hey, you know what? Shows that first thing that it did was it called the parent class. Parent class is, oh, I am the parent class. And then it called the child class and said, guess what? I am the child class, which is this guy right here, the subclass. And it said, I meant car, not care. Let car equal sports car, which is fine, not care. And so then what it does is that's the initialization. It calls this guy and then it prints this. But in order for that to work, it has to start, as you see, it has to start at the parent class and work its way down to the child class. So hopefully that makes a little bit of sense there. So this is perfect 101 object-oriented programming language. So we'll mark this as step 5. And now what we're going to do is we're going to add another override up in here. So we already have this model right here. And then we're going to add an override function. So we'll do an override function. And this will allow us to override what we existingly have. So we'll use the drive code that we have. And what we'll do is we'll just change it around a little bit. We'll say current speed plus equals and speed increase. Now we'll just times it by 5, a different algorithm. So now that allows us to utilize a different one. So if we didn't want to use, where's it at? This one right here, touch the parent, we can come down here to the child and increase that size, that value. So we'll say step 6 and mess around with this stuff code type of aspect of it. Make sense of this a little bit and explain why I did this with the override down here. So initially, this is our initial class, which is our main class, and you know, whatever. So the speed that we did over here, we did times 3. So just think of different vehicles. So take a moped. Moped, compare it with a motorcycle. Moped, I think max speed is like 80 miles per hour, which is pretty fast on a moped. It might even be 60 miles per hour. But you take a motorcycle, you know, you could go up to 120, 140 miles per hour. You're not going to be able to keep the speed. So that's kind of how this works, is we give it an initial value, but the reason that we did the override is we wrote a sports car. So in this case, we said a Pontiac Trans Am. It's going to go faster than, say, a Toyota Camry. Then say we had a motorcycle, it would go faster. So we could, and then we'd have different motorcycles. We might have a Harley Davidson, that's more of an enjoyable bike, goes pretty decent. But then if you add like a Ninja, like a sports bike in, obviously you're going to have an override for that because it's going to go even faster. So that's the whole reason for a different override, so that we could accommodate the different speeds. Hopefully that makes sense. That is my little demo on Inheritance. So thanks for watching, guys, and I'll talk to you again. Bye.